part. Now let's solve our fx. But the problem here, if you can see, we have two fx. We have the first one is exponent to t, and the second one is t. So I just want you to separate it to become fx1. So we will use fx1 to find yp1, and we will use fx2 to find yp2. Okay, and our yp then will be yp1 plus yp2. Okay, let's take the first fx. So we have exponent to t, so we compare with c t to the power of n exponent rt. So our c is 1. We cannot have t in this one, so we have t to the power of 0 exponent to t. Okay, so from here you will get your value of n is equal to 0, your value of r is equal to 2. Because of your value of r is not equal to any value of lambda here, so your s is equal to 0. Okay, so now you can generate your yp. So your yp will be x to the power of s, so your s is 0. Okay, your n is 0, so you have a naught inside here exponent to t. Okay, so your yp here will be a naught exponent to t. So you will have your yp prime to a naught exponent to t, and you will have your yp double prime for a naught exponent to t. Okay, so now when you already have your yp prime, yp double prime, and also yp prime, yp double prime, yp prime, and yp double prime, you can substitute it inside your differential equations to find the value of y naught. Okay, so we will substitute inside our differential equations here. So we have yp double prime, so our yp double prime is 4a naught exponent to t minus with 3 prime, so minus 3y prime is 2a naught exponent to t minus with 4 times y, so 4 our y is a naught exponent to t equal to our fx. So our fx is exponent to t. Okay, this one is the first fx. Okay, so now we expand this equation, we will get 4a naught exponent to t minus 6a naught exponent to t minus 4a naught exponent to t equal to exponent to t. Okay, so 4 minus 6 is negative 2, negative 2 minus 4 is negative 6. So you will have negative 6 a naught exponent to t equal to exponent to t. Okay, you can cancel out et in the both side. So you left with negative 6 a naught equal to 1. So your a naught equal to negative 1 over 6. So when you already have your a naught, so now your first yp is negative 1 over 6 exponent to t. Okay, so this one is your first yp. Don't forget that you have 2 yp because you have 2 fx. Okay, so this one is your first yp. Okay, so let's solve for the second fx here. So your second fx is t. Okay, we do the same process. Okay, we compare t with c t to the power of n exponent r to the power of t, r exponent to the power of rt. So our c is still 1. We have t, so our t is t power of 1, and we don't have exponent, so we have exponent 0t. Okay, because exponent 0 is equal to 1, we cannot see any exponent in the term here. Okay, so now we will get the value of n is equal to 1, the value of r is equal to 0, and because of the value of r is not equal to any value of lambda here, Okay, so because our lambda here is equal to 4 and 1, 4 and negative 1, because the value of r is not equal to any value of lambda, so our value of s is equal to 0. So now we can create our second yp. So our yp is x to the power of s, so x to the power of 0. Our n here is 1, so we start with a1 x1 plus a0 exponent 0t. Sorry, all x now is t. So we have t. Okay. So t to the power of 0 is 1, exponent 0 is 1, so we have our yp equal to a1t plus a0. So we have our yp prime equal to a1, and we have yp double prime equal to 0. Okay, so now we substitute this yp prime and yp double prime in the differential equation here. So we have double prime. So our double prime is 0, minus with 3 times first prime. So minus with 3 times our first prime is a1. Okay, minus 4 times with y. So minus 4 times with our y here is a1t plus a0 equal to fx. Our fx here is t. Okay, don't take both. Okay, don't take both fx here because we solve it separately. So our fx for the second one is t. Okay, now we substitute or we expand this equation. We will get negative 3a1 minus 4 a1t minus 4 a0 equal to t. So what you will have here is negative 4 a1 t minus 3 a1 minus 4 a0 equal to t. So we do a comparison, left hand side and right hand side. So here is the term that have t, we compare with the term that have t here. Okay, so we will have negative 4 a1 t equal to t, so negative 4 a1 equal to 1, so a1 is equal to negative 1 over 4. Okay, so this one is the value of a1. Now we want to find what is the value of a0, so we take the second term here to be compared. Okay, the second term here, negative 3a1 minus 4 a0 without variable is equal to, here we have plus 0 times t, right? 0 times t is 0. Sorry, plus 0 without variable here. Okay, plus 0. So we can compare. We have negative 3a1 minus 4a0 is equal to 0. We already have a1 equal to negative 1 over 4. So negative 3 times negative 1 over 4 minus 4a0 equal to 0. So we have 3 over 4 minus 4a0 equal to 0. So we have negative 4a0 equal to negative 3 over 4. a0 equal to 3 over 16. Okay, so when we already have a1 and a0, we just need to substitute back in our yp here. Okay, substitute the value of a1 and a0 in our yp. So we have our second yp equal to a1t plus a0. So our a1 is negative 1 over 4t plus 3 over 16. Okay, because we have two yp, so now we want to find the overall yp. We adding up the first yp. So we have the first yp here, negative 1 over 6 exponent 2t, plus with our second yp here, so this one is our yp. Okay, so now we can find the full solution of our differential equation y equal to yc plus yp. Okay, so just now we find the yc, so this is our yc. a exponent 4t plus b exponent negative t, okay, plus with our yp, minus 1 over 6 exponent 2t minus 1 over 4t plus 3 over 16. Okay, so this is our solution. But then, don't forget that we need to substitute back the value of t with x. Okay, so just now I have already showed to you that t is equal to ln x. So now we substitute all t with ln x. We will have y equal to a exponent 4 ln x plus b exponent negative ln x minus 1 over 6 exponent 2 ln x minus 1 over 4 ln x plus 3 over 16. Okay, this one can be written as a exponent ln x to the power of 4. I bring the 4 here at the back and it become power, plus b exponent ln x to the power of negative 1 minus 1 over 6 exponent ln x to the power of 2 minus 1 over 4 ln x plus 3 over 16. Okay, now exponent and ln can be eliminated. So this one is eliminate, this one is eliminate, and this one is also eliminate. So what we left here is a x to the power of 4 plus b x to the power of negative 1 minus 1 over 6 x to the power of 2 minus 1 over 4 ln x plus 3 over 16. So this one is the solution to our second order ordinary differential equation.